So, with the organic chemistry reactions, I'm just going to introduce now the different types, and then I'll do them one by one. I'll do examples of them one by one. So we have the first reaction, I would say, is combustion. Of hydrocarbons. So we'll do the combustion of alkanes, alkenes, and alkynes. Only the ones with carbon and hydrogen as part of the molecule. So that's our first reaction. Okay? Now these reactions are reactions with oxygen. Combustion, oxygen is the only element that supports combustion. So it's the oxidation, or the reaction with oxygen. That would be your combustion reaction, because oxygen is the only element that supports combustion. And what do you get out of this? You get fire. You get high temperatures. These chemicals are extremely good fuels. Your petrol, your LP gas, your diesel, they are good fuels. The combustion of them will lead to fire. Lots of heat is released. Okay, so they are exothermic reactions. Then, if we have unsaturated molecules, the unsaturated molecules can undergo addition reactions. So addition reactions is the second type.
Sorry, you experience exothermic reaction between the hydrocarbons?
Yes, the combustion of hydrocarbons is exothermic. Okay. Addition reactions are reactions of the alkenes or the alkynes, and you're going to break double or triple bonds to add atoms. So if you add atoms to a double bonded molecule or a triple bond, a molecule with a double bond or a molecule with a triple bond, you have an addition reaction. Yes, Sandy? No, that's not an addition reaction, it's the reaction with oxygen. Don't worry, we'll get there. Just take what I'm saying now. Yes.
Is combustion like adding oxygen to those three?
Yes, it's the reaction with oxygen, not the adding oxygen. Reaction with oxygen. Addition reactions is where you break a double bond or you break a triple bond and you add more atoms to the carbon chain. The third one is the type of reaction where you break off from the carbon chain and you put other atoms in the place of the hydrogen. So they are called substitution reactions. So substitution reactions is, for example, where you remove an hydrogen and you put something else in its place, or you remove a chlorine and you put something else in its place, or you remove a hydroxyl group and you put something else in its place. So you're going to remove a hydrogen from an alkane, or you're removing and put something else. Or you're removing an halogen. Can I use the X for halogen? Can I use the X for an halogen? So the X could be, the X is an element of the fluorine, the chlorine, the bromine, the iodine. Those four halogens. So the X replaces the halogen. So you're removing an X from an haloalkane, and you're replacing it with something else. Or you remove the OH, the hydroxyl group, from what? From an alcohol, and you replace it with something else. You're understanding my note? So a substitution reaction is when you remove a specific type of atom from, or the hydrogen from the alkane, or the halogen from the haloalkane, or the hydroxyl from the alcohol, and you're putting something else in its place.
So you see, for the combustion of hydrocarbons, right? The hydrocarbons are reacting with oxygen in order for that reaction to take place. What do the alkenes and alkanes, the addition reactions, need to react with in order for it to do?
They can react with water, or with a base, or with an halogen. They can react with things like that to break the double bond and add those atoms onto the molecule. We'll still do the specific examples. So here, so to answer Sumani's question, you can add hydrogen to the alkene or the alkyne, or you can add an halogen, or you can add a hydrohalide, halogen joined to an hydrogen. So you can add different things. When you have an alkene or an alkyne, you can add hydrogen, or you can add a halogen, or you can add an HX where the halogen is joined to an hydrogen, or you can add water. or you can add hydroxide. Okay, are you with me? Last one, I think. What am I missing? If you look in your textbook, what am I missing? I've done elimination. Good. Thought so. Can I move to the next slide? Oxidation and combustion is very much the similar thing. It's just with the alcohols, the oxidation forms a different products. But we'll go through them. I just wanted to bring you into the picture, the whole picture at once. So the word addition means that you're going to add more atoms to the chain. You can only add more atoms to the chain if there's a double bond or a triple bond. The word substitution means that you're replacing one atom or maybe two atoms with another type of atom. But we keep the carbon atoms the same. And now elimination. Can I move? So the fourth type of reaction is elimination. What is the word telling you? So elimination reactions, you are removing atoms from the carbon chain. So we can have elimination reactions with alkanes and it will make an alkene. Am I right? If you look at this, the general formula for alkanes, CnH2n plus 2, and you take two hydrogen atoms away there, what will you get? CnH2n. Okay, so elimination reaction of an alkane will take it to an alkene. And haloalkane or alkyl halide, whatever you want to say, haloalkane, it will also take it to an alkene. If you break the halogen off from the carbon chain, it will go with a hydrogen. You'll see when we do the examples. You can do alcohols. If you take an alcohol molecule and you break off the OH group from it, you'll have an alkene. Now it's becoming boring because alkane goes to alkene, haloalkane goes to alkene, alcohol goes to alkene. Alkene will go where?
Alkyne.
Clever. So you take a saturated compound and you make it an unsaturated compound. Or you can take the alkene with its CnH2n and you can change it to an alkyne, CnH2n minus 2. You take two atoms off. Usually you remove two atoms from a molecule. Yes.
You just do the German formula for the haloalkane, so C2alkene.
What must I do?
the general formula on the same day with hers.
Okay.
And alcohol.
Okay. Okay, now I can use a general formula for the alcohols with one OH group then. So how would that look like? CnH2n plus 1 OH. And that will go to CnH2n. Wait, I need to figure this out now, because COH, I mustn't put that H with the OH. H2. Come on, my brain is doof now. So if it's one carbon, it will have 3 hydrogens plus the OH. Okay, so I am right. If it's got 2 carbons, it's got 5 hydrogens plus the OH. Okay, so that is what I'll write as the general formula there. And the haloalkane will be similar. The OH is just replaced by the X. So CnH2n plus 1 X will go to CnH2n. And we will still look at what happens to the things that are broken off. So now we're going to do examples, and I'll start with the easy ones, the combustion ones. Now all you need is a little spark, and this compound in the presence of oxygen will ignite. So let's start. Choose, Eva, the compound from the alkanes that you would like to use. Propane.
Yeah.
So propane tells me C3H8.
I'm gonna pick octane.
No. Okay. We mix this with oxygen, and it will make 2 products. It will form carbon dioxide. That increases your carbon footprint in the atmosphere, and water, vapor. At the temperature it is formed, everything here will be gases. Oxygen is a gas. This propane is also a gas. I think up to butane is gases. From pentane they turn into liquids. And I know from grade 11 that this thing will be less than 0. The change in the heat of the reaction is, yes, giving it off, so it's exothermic. Delta H is negative. Now the thing comes in with the balancing. Let's see. Who can balance?
It's change carbon to 2, CO2 to 2.
Only 2.
3 to 3.
I'll start with the hydrogens.
And
You
so
put a
is
4 by
it
8
4?
4.
And then isn't there 3 by
3 is a problem. 5 here.
That's 10.
Oh yeah, that works out. Yeah,
Got it.
Yes.
Let's do the octane one. So octane is C8 H18. Okay, and this will be a liquid. Plus O2, which is a gas, goes to, I know for sure, like I know the reactions of the acids with the different substances. If this hydrocarbon combusts in oxygen, it will make carbon dioxide and water vapor, and there'll be a lot of light and heat coming your way, so delta H will be negative. Go for the balancing. Yes,
correct me if I'm wrong, the negative indicates the energy we produce.
yes, you're right. Yes.
You said from butane until upward, the hydrocarbons are butane is different.
Butane is still a gas. Here I've got butane in this container.
Yes, ma'am.
It's a gas.
So, ma'am, I'm trying to say is that okay, that's only when it's reacting.
No, butane is a gas. At room temperature and pressure, it's a gas.
Then why is it liquid? Is that
Because it's under high pressure, so the molecules are forced in a small space, so they liquefy. The gas laws. If you increase the pressure, the gas will turn into a liquid. Right, lovies, if I start balancing this and I go for the hydrogens, I'll see that I'll have an odd number of oxygens on the product side. If I do this, I'll have 9 plus 16, that's an odd number of oxygens. So an odd number of oxygens, 25, no, 25. 25 times 2, no, 50. Okay, I'm going to say 25 halves times 2. That will make 25. Am I right? I'm playing with mathematics now.
what did you say?
Listen to me, I'm playing with mathematics. On this side, I've got 25 oxygens. To get 25 oxygens here, I say 25 over 2 times 2. Isn't that 25? But you can't have a fraction in a balanced equation, so I just multiply everything by 2. Then that 25 will be 25. And this will be 16. And that will be 18.
Wait, this is recorded.
So, when you are using this, you're going to have an odd number of oxygens on the other side if you balance the carbons and the hydrogens. And then you just multiply everything by 2, and it will sort itself out. It's a little mathematical trick that we can do to sort it out.